Hello class, welcome to the penultimate topic, well subtopic for the stage 4, which is the pulley, la polea. And this is going to be a very short lesson. You're going to see why. So basically guys, we will investigate two types of pulleys. Pulley, the type 1, which is a fixed pulley, which looks like this, and the type 2, which is a mobile pulley, which looks like this. And that's all we're going to analyze. So this is the usual pulley that you may have seen before. What do we have in here? What aspects or what parts do we have in here? Well, you must notice, give me a moment please, let me fix this thing. Okay, so I was saying, what do we have in here? We have basically the ceiling. This solid block is basically representing the ceiling. And then the pulley consists of one, you may call it a circle. It's kind of like a circle here, usually made of metal or wood, hanging from a rod. And this circle, or this pulley more specifically, it's not really a circle, can rotate around this axis right here. And there's a rope going through the pulley. And with the help of this pulley, we can actually lift objects like this by applying an effort in this direction. I'm pretty sure you have seen this thing. Okay, so let's read, guys. The fixed pulley offers no mechanical advantage. This type of pulley, guys, doesn't give you any mechanical advantage. What does that mean? It means that if, for example, let's suppose this load has a weight of 100 newtons. Let's assume that this is 100 newtons. Then the force that the user is going to have to apply on this other extreme of the rope will have to be also 100 newtons. So basically the effort, which is this force, right? This is the effort, is going to have to be the same as the load, which is the weight that you're trying to lift. So this pulley, this specific pulley, the fixed pulley, doesn't offer mechanical advantage like the other machines, right? If you remember, the lever, the inclined plane, and the wheel and axle all provide some sort of mechanical advantage, depending on the configuration, right? But in this case, this thing doesn't provide any mechanical advantage. It's only used for redirecting the force applied by the user, which, as we know, is the effort. So the effort will always be the same as the load we try to lift. That's basically the whole thing for the fixed pulley. That's the fixed pulley. Now the other type of pulley that we're going to take a look at is this one, which is the mobile pulley. And let's read. The mobile, let me draw the pencil. The mobile pulley in the configuration given below, in this configuration specifically, because there are many types of mobile pulleys. In this configuration, when you have the ceiling and then a rope and then the pulley right here attached to the load, or well, the load attached to the pulley, and when the effort is applied in this direction, try to memorize this configuration. When the configuration is exactly like this, then this pulley will offer a mechanical advantage of 2. What does that mean? It means that it's going to amplify the effort force by 2. So in this case, suppose that the load is 100 newtons. You want to raise a load which weighs 100 newtons. Then the effort that you're going to have to apply in this direction is going to have to be 50 newtons only. Why? Because this configuration amplifies the effort force by 2. So that's, I mean, this is going to be amplified by 2, and therefore you're gonna be able to raise this load of 100 newtons. And it's always that way. This configuration of pulley in this precise way offers a mechanical advantage of 2. Always, no exceptions. So those are the only types of pulleys we're gonna take a look at, guys. Let me tell you how they work. Take a look at this video. It's very short, but Okay, so this is the fixed pulley, right? You are the user, you're applying the effort in this direction, and the load is being raised. So it just works like that, right? It's a very simple idea. And on the other hand, the movable pulley or the mobile pulley, take a look at this. You have the rope being attached to a rigid place, ceiling or something, and then the pulley is right here. And why is it called the movable pulley or the mobile pulley? Well, because when you actually are using this machine, you can see that the pulley is also is moving, right, along with the load. The effort is being applied in this direction, and take a look at what's happening. You see? So that's pretty much how they work. By the way, I discovered this video on internet. It says construction workers use makeshift pulley to lift heavy sacks to top floor. Makeshift es como la hicieron ahí en el momento, la improvisaron. And take a look at there is one construction worker in here, and they wanna lift very heavy sacks of, I think, cement or something, and and they do it in this way. Sorry, it's very cool. Look at that. They're using their own weight to lift the sack, and they are relaying one another, like they're helping one another. Look at that. That is perfectly possible, and it's safe. You know, it's not. It may look at something very dangerous, but no, it's relatively safe. So in this case, guys, I mean the pulley is, I think, over here. I think it's the pulley is right here, more or less. I think so. So this is a type of fixed pulley. Why? Because the pulley is right there, right here, and it's not moving. It's not moving. It's a fixed pulley. Okay, so that's how it works. Okay, let's solve two very quick problems. Problem number one. A fixed pulley is used to lift a mass of 50 kilograms. How much effort is it necessary to lift this load? So we have a fixed pulley, and when I have a fixed pulley, I know that there is no mechanical advantage. No mechanical advantage. And basically what that means is that this pulley won't help you amplify your effort. It will not amplify your effort. Okay, that's all it means. That's all this phrase means. No mechanical advantage. So let's see. We have a fixed pulley. Let's draw it very quickly. We have the ceiling, and then we have the rod, we have the pulley, we have the rope, and then let's suppose that from this, well, this is supposed to be straight. You get the idea, right? And then we attach the load of 50 kilograms to the rope, and we need to apply the effort in this direction. Okay, so how much effort is it necessary to lift this thing? Well, let's see. Even though I'm telling you that this is the load, I'm not saying that 50 kilograms is the load. Remember, the load is supposed to be a force, and it's supposed to be the weight of the object you're trying to lift. So just get the weight of this object, mass times gravity, right? So it's going to be 50 kilograms times 9.8 meters per second squared. And when you calculate that, you're going to get 490 newtons of weight. And that's the load, guys. That is the load that I'm trying to raise. This is not the answer, though. This is the load that I'm trying to raise. And now let's answer the question. How much effort do I need to lift this load? Well, the same. Even though, I mean, this is not technically the answer. The answer is this. The effort needs to be 490 newtons. Why the same? Because I'm using a fixed pulley, and when you use a fixed pulley of this type, there is no mechanical advantage. This pulley will only help you to redirect the force. In this case, the force is being applied downwards, the effort force, and the output force, or the force that it's applied to the load, is being directed upwards, right? Which is what you want to do. You want to raise this object. So this is the answer. The effort should be 490 newtons. There you go. Very simple thing. Second problem, a mobile pulley is used to lift a load of 1000 newtons. How much effort do we need to lift this load? Well, very simple, right? We don't even have to draw anything or write any equations or anything. No. As long as I know that I'm using a mobile pulley of the type I showed you guys, you need to make sure that, I mean, basically for us in this course, when I say mobile pulley, I'm referring specifically to this type, to this exact configuration. Why do I say this? Because there are many types. Let me show you. There are many types of configurations, many types. For example, look at this. This is also a movable pulley, but you can see that there are two pulleys. There is one, there is two. Same in here. Can you see? Look at this configuration. Look at this. There are many types of mobile pulleys. Can you see? But when I say mobile pulley, I'm exactly referring to the one I showed you, which is this type. And this is the one that has a mechanical advantage of 2. For other configurations of pulleys, you may have a greater advantage, but we don't take a look at those things. Okay, so what do we have to do in order to solve this problem? Well, it's very simple, guys. If you want to lift a load of 1000 newtons using a mobile pulley, how much effort do you need? You need half as much. You see why? Because the mobile pulley will amplify your effort force by 2, therefore it's going to convert it to 1000 newtons, and therefore with this 1000 newtons you're going to be able to lift this load. As you can see, there is no need to write any equation, there is no need to draw the mobile pulley, there is no need to anything. This is a very simple, these two problems, any problem involving the fixed pulley and the mobile pulley in this course is extremely simple to solve. It's just a little reasoning, period. That's it. Okay, class. So that settles this very short subtopic, the pulley. Okay, there's nothing more to say. And then there is just one more subtopic to cover, which is 4.6, which is about compound machines. I'm not gonna be doing that one. That one was done by another teacher at CIDEP. One year ago. It's well done, so I'm just gonna give you the link for you to see. And that concludes the whole semester, guys. Thank you so much, and see you in the next one.